the structure of this is going to be that I'm going to give a short talk on serverless as an architectural pattern, and then we're going to get into a hands-on lab. For everybody watching the recording, we may not actually do the lab as part of the recording because it's sort of self-paced. So I've put the links to the first few steps that you'll need for the lab. The first is for your IBM Cloud signup. That's optional, but it really helps you get through the lab faster because you don't need to do any configuration on your local environment. And then the lab instructions are at that second link there, ibm.biz/JSLA 2019-lab. And that's just a GitHub README. It'll walk you through all the different steps of the lab. If you'd like to get started on it while I'm talking, by all means, please go ahead, open up the lab instructions, and go along at your own pace. And then I'll be around after my talk to help everybody answer any questions. So I don't like it when people do a lot of like really commercial talks. So I've decided to call this talk why you should purchase IBM Cloud Services for your loved ones this holiday season. So let's get started. Don't you love the look on a child's face when they get their first IBM Watson Cloud service? You know, it'll only cost you about $250 a month, and it'll really help my job metrics. Everybody go sign up for IBM Watson today. Also, the elderly really love IBM Cloud. If you'd like to get an IBM Cloud for your grandmother, here's Santa giving IBM Cloud to a resident of a care facility. Don't make the mistake and give your grandma an Azure service. She won't enjoy it. Okay, no, sorry. We'll go with the original. We'll go with the original serverless workshop. So hi, I'm Dave. I'm a developer advocate for IBM from San Francisco. So I don't understand what all this traffic is all about. I run the SF JavaScript meetup up there. I help run the IBM Developer SF meetup. We actually do 2 or 3 events every week, and one of those events is always online. So you may want to check out IBM Developer SF meetup, even just for the online events. We usually do them Wednesday mornings, Pacific time. And then I also run Forward.js San Francisco and Ottawa, which is a JavaScript conference that we're doing 2 of this year. And I love working with hackathons, meetups, stuff like that. If you have any questions while I'm giving this presentation, please feel free to raise your hand because I love to cater to sort of like what you're interested in. But just as a FYI, I am a lowly developer, so when I'm talking about things involving DevOps and deployment and stuff like that, I'm going to be looking at that from a developer perspective rather than a software architecture perspective. So my goal today is to actually educate you about some of the open source things that we had on the meetup description. I want to learn from you about what you're using in your company today, what you're using sort of on your side projects today, and also walk through the labs and sort of solve these problems together. Here's our agenda. It looks daunting. It was daunting to put together these slides, but it actually goes pretty fast. And also, if there's something that you're particularly interested in, we can dive into that a little bit more. But we're going to cover what is serverless. We're going to go over microservices as an architecture and how that sort of maps to serverless. We're going to talk about why you might use serverless, some use cases, considerations, different languages that you might use. We're going to talk about Apache OpenWhisk, which is what we're going to be implementing in the labs and some of the terminology there. Finally, we're going to do a review and then jump into the lab. And again, if you want to get started on the lab, here are the links again if you want to copy those down. While you're doing the interactive portion of this, you'll probably have one tab open with each of these links, so you could feel free to load those up now. The first one is going to be your sign up for your free IBM Cloud account. Again, everything that we're doing today is going to be totally free. You're not even going to put a credit card in. It's not like we're going to charge you in 90 days, and then you're going to be like, oh, Dave, IBM, no, why? No, it's totally free. And then the lab instructions, that's just a link to GitHub. So I don't know if everybody heard, but my company, IBM, recently completed their acquisition of Red Hat. We paid $34 billion for Red Hat, I think the news release said. Yeah, and we didn't even sponsor the pizza tonight, so sorry about that. So let's talk a little bit about what is serverless. Anybody here actually using serverless in production at their job or on one of their projects? One person? Good job. Okay, you have to leave. No, just kidding. So the projected market for serverless architecture by 2025, according to one of these studies, is supposed to be 21.99 billion. So a very exact number that will almost certainly not be hit exactly. Apache OpenWhisk is the project that we're going to be using in the lab. You can actually look at the repo on GitHub. It has over 2,600 commits from over 100 different contributors. A lot of those are from IBM. So IBM has a big commitment to open source in addition to Red Hat, obviously. So I'm just going to read this because the text is a little bit small. But what is serverless? Serverless computing refers to the concept of building and running applications that don't require server management. It describes a finer-grained deployment model where applications bundled as one or more functions are uploaded to a platform and then executed, scaled, and billed in response to the exact demand needed at that moment. It refers to the idea that consumers of serverless computing no longer need to spend time and resources on server provisioning, maintenance, updates, scaling, and capacity planning. Instead, all of these tasks and capabilities are handled by a serverless platform and are completely abstracted away from the developers. One of the interesting things for me about this paragraph, and there's actually the link to the GitHub where I took this from, and all my slides, by the way, are available on my GitHub. So if you go to the lab link, it's just github.com/drnugent. I already posted the PDF to these slides earlier today. But in the third paragraph, it refers to the idea that consumers of serverless computing. Consumers of serverless computing in this context means you. It means the developers, right? The developers we're the consumers of serverless computing. The end users, the person using the app, the person using the website, they are not going to care one way or the other whether something is using a microservice architecture built on a serverless platform or using a monolith that's running on bare metal somewhere. Ideally, it's totally abstracted away. And the benefit is really going to be for you. It's for your team. It's for your project. We'll talk a little bit more about that later. So what is serverless? We can look at serverless as sort of the end result of a process that started with running applications on bare metal. And then as we went through with an increasing focus on business logic and decreasing concern over stack implementation, over time, we eventually moved to a point where we were running virtual machines, right? We would have virtual machines that were running on a hypervisor. Each virtual machine had its own operating system. Then a few years ago, you probably heard about containers entering the system, where you would actually run applications on a containerized infrastructure, and you'd use something like Kubernetes to run your orchestration layer. But if we look at functions as a service or serverless, we're actually seeing that it's even more abstracted, and we're exhibiting even less control over the stack implementation, but we have more and more of a focus on business logic. So the idea, as far as sort of like benefiting your team if you're building an application, is on your team, maybe you wouldn't have somebody that's focused specifically on DevOps, and you could use that headcount for another programmer or another designer or another engineer of some kind. This is a quote from bash.org that I think exhibits what serverless is in an ideal world. This person says, I've lost a machine. I've literally lost it. Responds to ping. It works completely. I just can't figure out where in my apartment it is. So here's this person has this, not thinking of it from a serverless perspective, but this is something that we can look at it as a serverless perspective. They have a service that's running. They don't know exactly where it is. All that they know is there's a machine somewhere that's running it and it's working properly. And so that's one of the values of software architecture. As Steve Jobs said, if you call it software architecture instead of software planning, your salary goes up by 50%. So I encourage everybody to think of themselves as software architects. And this is actually not a real quote. I wanted to like spice things up in my presentation with like a really famous person. To my knowledge, Steve Jobs never really said this. I kind of wanted to feel important, but as Abraham Lincoln said, don't believe everything you see on the internet just because there's a quote with a picture next to it. So serverless is running code without provisioning or managing servers. No offense to the IBM mainframe team with the Z servers. It was very difficult for me to find pictures of things that were serverless. To find a picture of something that's not a thing that so there's just going to be a lot of pictures of servers. So let's talk about microservice architectures. Is anybody familiar with the idea of microservice architectures, even like you've just read an article in a magazine? Yeah? Martin Fowler has an article on microservices, and the link is actually in this presentation on my GitHub. But the quote that I'll read to you is, in short, the microservice architectural style is an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms, often an HTTP resource API. These services are built around business capabilities and independently deployable by fully automated deployment machinery. There's a bare minimum of centralized management of these services, which may be written in different programming languages and use different data storage technologies. Anybody who is using an API to a third-party service as part of their application implementation is probably nodding along at this, because this is a very common pattern, especially if you're using sort of like a best-in-breed service. And here's a diagram of a particular way that especially microservice advocates would think about breaking down a monolithic application into a microservice architecture. Monolithic application being an application the way that we would have designed it, 20 years ago. There's a huge chunk of code and it's running on a server somewhere, a bare metal server. But these days, when we think about functions as a service, we can actually think about breaking down that monolithic application into microservices, making each one high availability, and then protecting against regional outage by having high availability microservices running in each region. This is on your different, your cloud vendor deployment, your AWS deployment, whatever it may be. Here, I'm not knocking monolithic applications because they're still really important, and there's no particular reason that you'd say, every application has to be a microservice application now, because there's lots of benefits of keeping all the code in one monolithic application. And I think in a lot of use cases, you're going to see monolithic applications continue. So it's not like this is a best practice for everything. It's a pattern that works well with serverless. So why should we use serverless? Why are you all sitting here listening to me ramble on, besides the fact that there was free pizza that I didn't even pay for? So with serverless, code runs only on demand on a per request basis. So a request comes in and then the code executes, but the code isn't executing before the request comes in, so you're saving money in that sense. Here's a good use case for why to use serverless. Let's say you have, this is an active users curve. It's obviously real data and not something that I just made up for illustratory purposes, but let's say that you're launching a new mobile game and you know that you're going to have a spike in the number of active users, but you don't know exactly how big that spike is going to be. Does anyone remember when Pokemon Go was released, right? Everyone was in the park, on Pokemon Go, trying to catch all the Pokemon and everything. And now nobody goes to the park anymore. But back then, everyone was in the park. And I remember seeing sort of like a prediction where they were saying, let's look at, in the worst case, we'll probably release it and we'll get X number of active users. And in the best case, we're going to get, 10X. And I think they were off by 2 orders of magnitude, right? It was just much more wildly successful than they could have imagined. If you don't know sort of what your number of active users or what your usage is going to be, but you know that it's going to be there, that could be one vote for implementing something as a serverless pattern. Also, let's say you know that you're going to get demand at a certain time, but you don't know exactly how large that demand is going to be. So maybe you're running a conference app. I know we do this. We don't know exactly how many people are going to be hitting the website, but we know that it's just going to be a ton more. Dealing with it on a serverless basis means that you don't have to pay for that usage if it's not being consumed. Also, let's say you have a mobile banking app. They have peaks in demand on payday, which is once every 2 weeks. So that's something maybe you'd use a serverless implementation. And here are some use cases. I won't go through all of these. We've already talked about some of them. But here's our sort of functions as a service here. Serverless backends. So maybe you've got something that's going to power a website or it's going to power a mobile application. Data processing. So you're going to have a bunch of data. You're going to feed it into a stateless serverless function. And then you're going to get some data back out. And that data processing maps nicely to a lot of the IoT device streams that we see out there, right? You've got a device out there in the field. The device is generating data. The data has to go somewhere. It hits the serverless endpoint and then gets stored in a database or processed and streamed out in another way. In the same way, conversational scenarios. These are event-driven stuff like chat, right? It's an event-driven architecture where something has to happen as soon as somebody finishes a chat message and sends it. Maps really well to serverless because only when that message is sent do you actually need to process it and use your processing resources. Event stream processing is just a generalized use case of what we've been talking about. And finally, scheduled tasks. If you know something is going to happen once every day, Doesn't make sense to provision resources for it 24 hours a day. You just want it to run when it's actually happening. So to abstract that out, if you're dealing with asynchronous, concurrent, easy to parallelize into independent units of work, beneficial for serverless. If you have infrequent or sporadic demand with unpredictable variance and scaling requirements, benefit goes to serverless. If it's stateless, ephemeral, without the major need for a dynamic cold start time, and we'll talk about that in a second, or if it has really high changing business requirements so that you'll actually need to increase your developer velocity. If you don't have people on your team worrying about DevOps, then it's much easier and faster to prototype. Some other use cases are static websites. Is anybody currently using sort of like a static site generator? Those have gotten super popular in the last 2 or 3 years. Yes, right? You still need some dynamic infrastructure behind that static site most of the time. For example, a contact form. Those serverless maps really well to static site generators. Automated backups, so that's a scheduled service. Bots, which could be very much an event-driven service. Uptime checks, policy enforcement, background jobs, and also the accelerated velocity in your team for prototyping. So let's talk about some considerations that you should make sure that you think about before you move to serverless. Languages. So I just went through and updated this earlier today. To my knowledge, this is the most up-to-date list of languages that are available on the 4 function as a service platforms. So for Amazon Lambda, they support Node, Python, Java, C#, PowerShell, Ruby, and Go. You can also use the runtime API to update additional languages. With IBM Cloud Functions, we do Node 10 and 8. I don't know that we have Node.js 6 on the UI anymore. We do Python 3, PHP 7, Swift 4, Go 1.11, and Ruby, but you can actually add any other language that you want via a Docker container. So I think OpenWhisk on its own allows you to do Java, but you can I've actually done a presentation for a Java user group where it was really easy to get everybody up and running and deploying a Java application into a container and running a cloud function. Azure has C#, F#, Node 10 and 8, which is becoming a pattern. Java, Python, TypeScript, PowerShell. PHP, for some reason, is an experimental preview or something. I don't know why. It's been around forever. And then Google Cloud Functions has Node 10 and 8, again, Python and Go. So one other consideration is that serverless or cloud functions are ephemeral. They're designed to be ephemeral. They're not going to be used for a long-running process. These are the time limits that I believe are up to date. Amazon and Azure, actually Amazon and IBM used to be 5 minutes now. Amazon is 15, IBM is 10, Azure is 10. Google Cloud Functions by default I believe are 1 minute, but it's pretty easy to extend that up to 9 minutes. So everyone's pretty much standardized around 10 or 15 minutes. You really don't want your function to be designed to run this long. However, there are ways to sort of extend the lifetime of your function by having that function kick off another function when it's about to die. I just talked to somebody last night who made a mistake doing that because I think his function kicked off 2 functions when it was about to die. And a few minutes later, suddenly his AWS bill was very, very high, and he had to implement a kill switch. Also, latency. So I mentioned cold start earlier. So it's nice to think that your cloud vendor is just going to keep a container running with your function in it, just ready for that request to come in. It doesn't always happen that way because you're not paying them to do that. And so there's this thing called a cold start where if your function hasn't been called in a while, it can take slightly more latency to call it that first time so that it can get provisioned on the server. And you have to think about the type of application that you're building. You can actually work around that cold start issue with scheduled invocations of the function. But of course, when you schedule an invocation of your cloud function, you're going to pay, even if it's a somewhat trivial amount, for that execution time. So if you're building a back-end app and you're passing a bunch of data between machines, maybe a cold start isn't going to be an issue. If you're launching a rocket into space, probably don't want to deal with that cold start issue. Maybe you'll want to use scheduled invocations or use a different design pattern. So let's briefly talk about Apache OpenWhisk. Here's some of the terminology that we're going to be using today. You have your source events. You have triggers. The triggers pipe data to rules. The actions, as a developer, this is all I really care about. That's where you actually write the code, and then you're going to deal with the results. A lot of the things that you'll see in your IBM Cloud control panel look like IBM products, and they are IBM products. But IBM has a real solid appreciation for open source, and we make a ton of contributions to open source. So when you see IBM Cloud Functions, that's actually just Apache OpenWhisk. So you can take the same function that you're running in your IBM Cloud Functions dashboard, and you can actually download and install OpenWhisk on your local machine. You can install it on another cloud provider. You can install it on IBM as a cloud provider, and you can actually run those functions yourself. When you see IBM API Gateway, that's just loopback. Cloudant is a database that has a free tier on IBM Cloud. That's just CouchDB, Message Hub, Kafka, all that. So these are just a few examples. All of the stuff that you're going to be learning here tonight is not tied specifically to IBM Cloud. You're going to be able to use it on whatever cloud vendor that you want. So just a quick review about all the stuff that I've talked about so far. Functions are stateless. They need some sort of persistence between runs. They're also ephemeral. If you're going to be deploying, you can actually use, there's a few different CLIs that you can use. There's the IBM Cloud CLI. There's also the OpenWhisk CLI. You also, when you're building and deploying an application, you want to think about, can you easily version your functions? Do you have source control? Can you monitor your functions? This is stuff that IBM Cloud also provides to enterprise customers or to startups. How do you avoid long-running loops or sort of like mini monoliths so that you can still run your application as a collection of serverless functions? How do you deal with cold starts? And then also, how do you track dependencies? So when you're deploying a larger application, these are bullet points that you're going to have to deal with. That luckily we won't have to deal with tonight because we're just going to be coding for about 45 minutes. So let's get to the labs. If you go to this URL, this is nearly the conclusion of my presentation. So if you go to this URL, then you'll be met with a 5-step lab. 3 of the steps are sort of the basic lab steps. If you can get through all 3 tonight, it's amazing. Congratulations, you're a serverless maestro. And then there's also 2 stretch goals. If you can get through those, then I think you'll probably be hired before you leave by somebody at Farmers. It's a lot of fun, but just like anything, you'll probably run into some hiccups. And so please feel free to raise your hand, ask me any questions, and I'll be happy to help you out. Also, last night, we found a couple things in the documentation that weren't quite clear, and so I was actually able to update that documentation. So it could be that the problem that you're having that you think is something wrong with your configuration might be just something that we need to fix in our documentation. So I will be super happy about that. One last thing that I wanted to mention before everyone gets started with their labs is if anybody is working at an independent software vendor, IBM actually has a really great partner program for ISVs where we'll give you up to $12,000 of free IBM Cloud credit, 10 terabytes of IBM Cloud object storage. You get a Watson Assistant 1-year free trial. Cloud Kubernetes, IBM Blockchain, if anybody's using Hyperledger Fabric. I love giving away free stuff. I mean, not that you shouldn't pay us for cloud services. You could do that too if you want, but free stuff. And so the URL is ibm.com/partners/start. Definitely recommend if anybody's working with an ISV, take advantage of this free program. I love giving away stuff for free. And yeah, that's it. Any questions? Your favorite slide was the Wi-Fi username and password? It's okay, I'm not offended. Any other questions? Pizza food coma? I understand that too.
So for a big implementation,
how
your pricing is positioned relative to your competitors?
That is a great question. The question was, for a large implementation, how does IBM Cloud compare to the competitors? So I know some stuff about IBM Cloud and Apache OpenWhisk. I know much less about our competitors.
Independent, you know that, right? But on the side, I work for the city of Los Angeles. We are looking now into...
Right. So my goal is to sort of educate people about serverless infrastructure, to let people know that IBM is supporting all this open source out there. Point to the salespeople, or do the comparison on your own. Find your.
I wasn't expecting to.
Yeah. No, absolutely. But I would encourage everybody out there to, when you're deploying something, right, go out and do the comparison on your own. See if you can find sample code, do the pricing analysis, compare IBM, Google, Microsoft, Amazon, and go with the vendor that works best for you. The thing I love about IBM is that all of the stuff that I showed you is open source, right? So it's not like you're running on some proprietary stack that you don't know exactly what's going on behind the scenes. It's all open, and we're like, hey, we built this great open source software. If you want, you can download it. You can run it yourself. If you want to pay us a little bit, we'll run it for you. Either way, I think you win. And for the other vendors, I don't know, but you should check it out. All right, so is everybody on the lab screen? So these are the 3 steps that you should give it a shot, see how far you can get through, create, build, and run a cloud-native Node.js serverless app, and then create a cloud-native Python serverless application that uses visual recognition. I know it's a JavaScript meetup. If you don't want to do that one, it's totally fine. If you want to go down Twitter and say, like, oh, Dave's making everyone code in Python at a JavaScript meetup, that's fine too. And then also to create, build, and run 3 serverless functions as a sequence, so you can actually have functions kicking off other functions, which is going to emulate sort of like how these might work together in a production environment. And then finally, if you like, you can configure the IBM Cloud CLI. If you get to step 5, creating a weather bot, just go have some more pizza. So a few things to understand about IBM Cloud. If you ever get lost going through all the different pages and everything, in the upper left here, you'll see just the words IBM Cloud. Click there to get home. If you want to get back to your serverless function, click the hamburger menu up here at the upper left and just go down to functions. If you get stuck on changing the input action, it's very, very strict about properly formatted JSON, including quoting the parameter names. So FYI. And then finally, when you get down to step 7 here in the first lab, you'll get this big long URL. It might not have a .json at the end of it. So I added a little troubleshooting tip here. Make sure you add a .json to the end of your call, and then you can add after that your parameter names. We had some questions about that last night. So while everybody's doing the lab, and feel free to interrupt me if you have any questions, once you start creating services, you'll actually see them on your dashboard here. So this is where you get to when you click IBM Cloud. It's just all your list of resources. You won't see your cloud functions here because they're not considered resources. You can get to them through the hamburger menu and just scroll down to functions. But if you do go to create resource, it's the big blue button. These are all the different services that you can create. And today I think we'll be using 2 of these. But you can see there's a lot of different services that you can create. And one of the cool things is on the left-hand side, if you tick this pricing plans light and free, these are all the services that you can get without paying for them. So there's a lot out there that you can do without putting a credit card number in. And I encourage you to try as many of them as you're interested in.
What's the benefit of this over AWS?
The benefit of this over AWS, it's better in every way. So There's a lot of cloud vendors out there. The big four are IBM, Google, Microsoft, Amazon, not in that order. And so the way that IBM thinks about it is that in the future, everyone is probably going to be moving more towards hybrid cloud deployments, where you sort of pick the best in breed for each different service that you want to run. Some of them will run on your private cloud, maybe in an on-prem data center. Some of them might run in a public cloud, maybe AWS, maybe IBM Cloud, maybe a combination. And so the key is sort of being able to pick and choose the best services for each application. So we encourage everybody to go out there and sort of, when you have a need that could be met by a cloud vendor, compare all the different cloud vendors and see which one is best, and then use the best service for that application. I do a lot of presentations about OpenShift and Kubernetes. And OpenShift is sort of like an opinionated, managed Kubernetes stack. And yeah, sometimes we say, oh, you need to run containers as root. Maybe OpenShift is not going to be the best for you. Maybe it's not going to work for your use case. But I think it's important to just sort of know what's out there and be able to compare them. You had a question?
How long, if you create a free account and you testing some app, how long does it take forever, or do you?
How long does it take before, how long does the free account work? We start charging you after 45 minutes. So I'll be long gone. No, so it's actually different for every account, but generally the idea is that if it's a light account, then it's free forever. You don't even put your credit card number in, which is the way to do it. I encourage you, don't put your credit card number in unless it's your company's credit card number, in which case I don't really care about that. But so a light account will be free forever, but you'll probably notice some fine print saying something like, if your service is not accessed or if the endpoint is not hit in 30 or 45 days, then it'll be deprovisioned. So that's the downside to the light account, is that if you're not using it every month or so, then eventually you'll lose it. Not lose it forever, you'll still be able to go back in and create a new one, but the data on it will be lost.